The method of integration by parts is very useful. We use it quite a lot in C4, and it's used when you have two functions of x multiplied together that you need to integrate. So we start off with this rule, which you should recognise as the product rule for differentiation. So we start with that, and then we just add to each of those terms an integral with respect to x. So the integral of that term with respect to x equals the integral of that term with respect to x plus the integral of that term with respect to x. Okay, so the first one of these terms, if you're differentiating uv with respect to x and then integrating it with respect to x, you're going to get back to uv. The others don't simplify, so we'll just write them as they are. So u dv by dx dx plus v du by dx dx. Okay, and then we rearrange that, so we have the integral of u dv by dx dx equals uv minus the integral of v du by dx dx. And that is actually the formula for integration by parts. It doesn't look very nice at the moment, but once you start using it, you'll see that it's quite straightforward, and it appears in the formula book, so although you will know it by the time you need it anyway, but there it is if you need to refer to it. Okay, so let's look at a few examples. Okay, so this one, we've got x is one of our functions and sine x is our other function. So in order to use the formula, we need to make one of those functions u and the other one dv by dx. So we're going to choose one of our functions to be u and the other to be dv by dx. Then if we look at what we're going to use on the right hand side, we need to have a du by dx term, so we need to be able to differentiate the u, and we need a v term, so we need to be able to integrate the v. So you can sometimes just try either way round, but a good thing to do is to think, well, which of these functions is going to get more simple by differentiating? Rarely things get more simple by integrating, but they sometimes get more complicated by integrating. So this time we're going to take our x is u and our sine x is dv by dx. Reason being that when you differentiate or integrate trig functions sine and cosine, they don't get either any more complicated or any more simple. So that whereas x, when we differentiate it, just gives us 1, so that's definitely simpler. Okay, so our v will be minus the cosine of x. Okay, so that's everything we need in our formula now. Okay, so our u and our v dx, so that's the left-hand side of the formula. So the right-hand side is uv, so that's going to be minus x cosine of x, u times v, and then minus the integral of v du by dx. So that's minus the integral of 1 times minus cosine of x dx. Okay, using our two terms at the bottom of the substitutions there. So we've got minus x cos x, we had minus and then another minus, so it's plus the integral of cosine of x dx. Okay, so minus x cos x, the integral of cos x is sine x, so plus sine x plus c. And if we wanted to, we could check. And the way to check would be to differentiate our answer. So if we're going to differentiate minus x cos x plus sine x, we hope we'll get back to x sine x. So first term we need to use the product rule. So we've got minus x times the differential of cos x, which is minus sine x, plus cos x times the differential of minus x, which is minus 1, and then plus the differential of sine x, which is cos x. So there we've got x sine x minus cos x plus cos x, so we have indeed got back to what we wanted, so we've checked that that's correct. Okay, so again we've got to decide what we're going to use for u and what we're going to use for dv by dx. So x we know simplifies when we differentiate it. E is another of those things that if you integrate or differentiate doesn't really become any more difficult. So it makes sense to me to say that our u is x and our dv by dx is e to the minus 3x. Okay, so we need to differentiate the x to give us 1 and integrate the e to the minus 3x. So that's e to the minus 3x divided by minus 3. So minus a third e to the minus 3x. Okay, so our uv, x times minus a third, so 1/3 x e to the minus 3x, and then minus the integral of v, which is minus a third e to the minus 3x, times du by dx, which in this case is just 1 with respect to x. So we've got minus a third x e to the minus 3x. Now we've got minus, they will cancel out to give us plus, but then when we integrate at minus a third of e to the minus 3x, we get minus a ninth e to the minus 3x plus c. Okay, and obviously we could, again, check by differentiating. You might want to do that. Okay, so just in case you thought they all started with x, this one doesn't. But again, the 2x plus 1 term is going to be the one we're going to use for u because it simplifies when we differentiate it. So we're going to make u is 2x plus 1, so therefore the dv by dx will be e to the x. Okay, so du by dx is just 2, and v is going to be e to the x as well. So that's all the bits we need for our formula. Okay, so we've got uv, so that's e to the x times 2x plus 1, and then minus the integral of v du by dx, so the integral of 2 e to the x with respect to x. Okay, so that's e to the x times 2x plus 1, minus the integral of 2e to the x is 2e to the x. And this time it was a definite integral, so we have to put the limits in. Now we could tidy it up first or put the limits in first, doesn't really matter. Okay, so let's just take out a term of e to the x. So we've got 2x plus 1 times e to the x minus 2. So that gives us e to the x, 2x minus 1. And then we've got to put our limits for x of 1 and 0 in. So putting in our limit for 1, we've got e to the 1, or just e, times 2 times 1 minus 1. And then putting in our limit for 0, we've got e to the 0 times minus 1. Okay, so that gives us e. E to the 0 is 1, minus e plus 1. So that's the answer to that one. Okay, now this one isn't so obviously an integration by parts because it isn't two functions multiplied together, but given we don't really have another way of integrating ln x, it's a useful, parts is a useful technique. So what we do is we stick a 1 times in there because we do know how to differentiate ln x. So we make our u, this time, ln x, and our dv by dx is 1. Okay, so if we differentiate ln x, we get 1 over x, and if we integrate 1, we get x. Okay, so back to the formula. So we've got uv, x ln x, minus the integral of v du by dx, so that's x times 1 over x dx. So that gives us x ln x minus the integral of 1 dx. So that's x ln x minus x plus c. Okay, now you know how to integrate ln x, you can use that in lots of other integrals as well. I'm sure you'll meet many.